In this session, we're going to be touching on some of the concepts of simulation, where we try to model the physical world in a virtual way. Now, we will do a very simple application or a very simple representation of some of these concepts, and some of what we will use will be the following. We will use timers. We will leverage the knowledge that you have gained from coordinate systems, especially within the browser from previous sessions. We will touch on some computational geometry. And when it comes to simulation, we'll discuss the topics of time and space and how do we move within these concepts using computation. When it comes to thinking on how to simulate a physical system or how to create a simulation, one of the concepts that turns out to be pretty useful is the concept of being able to schedule execution or computation into the future. Now, within the language, there is such a feature, and the command that we use is called set timeout. This allows you, once again, to schedule computation into the future. And that function call takes two parameters. The first of those is the function that you're going to execute, and the second one is the amount of time that is going to elapse before that computation gets carried out. So here's a simple example where we have a very simple function called say hello that simply writes hello world to the console. And then below you see how that computation is scheduled. You use set timeout. The first parameter is simply the name of the function, which in this case is say hello. And the second one is the time to wait. Now the units for that is milliseconds. So in this case, we're going to wait 2 seconds before that computation is carried out. Now, just as before, we're going to start off working on the browser console. And so I'm going to move next to the browser and I'm going to open up the console. So I'm going to move to the browser. I'm going to navigate through the menus, just like we did before. I'm going to go to more tools. And although the submenu appears off the screen, what I'm going to select is developer tools. Now, once you are on developer tools, the tab that you want is the one that says console. And so now within this page here, I'm going to replicate the example that I had on the slides. And so I'm going to start off by writing a function. And all I'm going to do is call it say hello. I'm going to then define the body of the function. All we're going to do, as mentioned before, was to say hello. And so I'm going to enter that now, hello world. I'm going to close that off. And I'm then going to close the function. Now, the next thing that I'm going to do is I'm going to use set timeout to be able to make that computation, to schedule that computation into the future. And the first parameter is the name of the function, which in this case is say hello. And then the amount of time to wait. In this case, I will make it 3 seconds. So I'm going to hit return, and a note about what you will see a number, most likely in this case a 1, and that is simply the ID for the timer. And later on, we'll discuss on how we could use this. But in 3 seconds after I hit return, we should see the hello world coming back. And we're now waiting, and as you can see, there it is, hello world. Now, if we go back to our slides, we'll see that there is an additional notation that we can use. And the notation is the following. We still use set timeout. We use two parameters just as before, but instead of putting the function name, we could put the function directly into one of those two parameters. So let me go ahead and illustrate that. I'm going to go ahead and clear here my console, and I'm going to go ahead and simply write set timeout. I'm then going to define the function. And so in this case, I will simply write function, say hello, and then I'm going to write the body of the function. Inside of it, I'm going to do the same thing as before. And then inside of that, the console log, I'm going to write hello world. Then I'm going to close the quotes, close the parentheses, and that's the function. Now, the second parameter is the timer. Let's make it here a little bit longer. I'm going to make it 4 seconds. And then I'm simply going to execute. Now, note that the first parameter is actually the function being written within the function call. And so this is the equivalent to what we did before. And so I'm going to go ahead and hit return here. And if this works, we should see in 4 seconds. And yes, there it is. Hello world. And whichever form you use depends on what's more comfortable to you. If you feel this is more compact and looks good, use this one. Otherwise, use the previous way of defining the computation to be scheduled into the future. Let's go ahead and go back to our slides. And so now it is your turn. This is a pretty important concept. This is a very basic timer. Go ahead and write an example of your own based on what you have seen. Open up the console. As I mentioned, navigate through the menus, write your set timeout, give it your function, give it the amount of time that you want to wait, and play with it a bit and push on those concepts. Make sure you understand them well. The next thing that we want to look at is not just scheduling computation into the future, but scheduling computation into the future that repeats. And in this case, the function that we will use, or the command, the instruction that we will pass, is set interval. This is part of the language, and just as before, we give it a function, and just as before, we give it a time. And in this case, the time refers to the amount of time that will elapse between subsequent calls to the same function. So this will run as long as the computation is in scope. That means as long as the page is open, or unless you stop the timer. But we will leave stopping for the future. For now, let's concentrate on how set interval works. As I mentioned, it is very much like set timeout, the example we just did, except in this case, it continues to call at that interval that we specify. So let's go ahead and try out the same example that we did before, and where we defined a function. So we will go back to our console, and I will define a function. Just for clarity here, I will repeat the definition. Here is the function body. Inside of it, just as before, all we're going to do is console.log. Inside of it, we're going to simply say hello world. And then we're going to close our quotes, close out parentheses. And below it, we're going to write our set interval this time. Not set timeout, but set interval. The first parameter is the name of the function. So in this case, it's say hello. The second one is the time between calls to the function. Remember, in this time, we're not calling only once, but this will continue to be called. So I'm going to set it at 3 seconds. I'm going to go ahead and finish that line. And then I am going to hit return. Now, what is coming back here is a static hello. And the console is smart enough to know that this is not changing. And all it's doing, it's increasing the little counter here next to hello world. You can see there we're up to 5, 6, and it'll continue to grow. And all it's saying is you're really writing to the console the same thing over and over. So instead of writing hello world a bunch of times, all I'm going to do is give you a little counter next to it. So you understand that that number is increasing. Now, just as before, as opposed to defining the function separately and passing it in as a parameter, we can define the function within the call to set interval. However, I will not demonstrate that here since it is the same thing that we did previously. Now it is your turn to schedule a repeating computation into the future. Once again, push on those concepts. Make sure that what you think is taking place is in fact taking place. Play with that time. Try to do it quicker, try to do it faster. If you get stuck or if your page for some reason freezes, reload the page, and that will clear the memory of the console and it'll get you back to square one. If all else fails, close your tab. And if you're really, really stuck, you can shut down the browser and start over. Now, the previous examples that we worked on were pretty basic. They were static. Nothing was changing. In fact, that's why on the console, we got that little counter on the side, because the console is smart enough to know that nothing is changing. You're really printing back that same message. However, when it comes to thinking about simulation, we often have a much richer environment. We're thinking through something that is changing. Oftentimes, and especially within the examples that we will look at today, we're moving in time and we're moving in space. And so this next example is looking at something where that function that is called is changing every time it's called. So here is the example. As you see, we start off with a counter, then we have a simple function, and then a set interval. So let's go ahead and write that on the console. I'm going to go ahead and open up my console once again. I'm going to reload the page to make sure that I've cleared everything within the page. And now I'm going to go ahead and write that code. I'm going to start off by creating a counter. And this counter is going to keep track of the number of times that my function that I'm going to define next has been called. And so I'm going to enter function, my function. That's going to be the name of my function, and then going to write the body of the function. Inside of it, I'm going to have two instructions. The first one is to increase the counter. I'm going to do that using ++, which means that every time that function is called, the global value of the counter is going to increase by 1. I'm then going to write to the console here the value of that counter. And so I'm going to enter here counter, and then I'm going to add to it the value of my counter, as you can see there. So that's all I'm going to enter for my function, a pretty simple function. And then I'm going to set my interval. And the first parameter is going to be my function name, which in this case is my function. And then I'm going to enter the time between function calls, which in this case will be 3000. So note that this is different than what we've done before. There is a state that's changing, and we are accessing that at those regular intervals, every 3 seconds in this case. So I'm going to go ahead and enter execute the command. And as you can see there, we have counter 1, counter 2. Next, we should get counter 3. And so this would continue to execute for as long as we wanted, unless we reloaded the page or we stopped the timer. So again, this is now more useful. We're keeping track in this case of how many times the function has been called. But as I mentioned, when we are trying to model something, there is a much richer environment and many more variables that we want to keep track of. Next, as part of active learning, I want you to think about what's taking place. Discuss it with your classmates. Can you explain what is taking place here? Can you explain how you could use this to model something you might want to think through? Could you take that same simple example and make it grow at a faster rate? For example, by 5. Could you make it grow at exponential growth? And how could you take those concepts of growth and use them to think or model something in the physical world or that you otherwise want to model? When it comes to simulation, there's a couple of variables that we often want to keep track of. One of them is time, and the other one is position. And these can be somewhat abstract concepts. And so I'm going to try to ground them here with an example of the physical world. And in this case, I'm going to take the example of somebody who is jumping forward at a certain interval, at a certain time. And so I'm going to go ahead and move forward. And this is the example, or it's meant to be analogous to one cycle of that interval, of moving forward in time a certain amount and moving forward a certain position. And so we could do that once again. And you can see here how we could model these variables within a timer and have some notion of something that's moving forward once again in time and also moving forward physically in physical space. So we talk about time and we talk about space. Now, the great thing when it comes to simulations is that we do not have to be bound to the physical world, which means that we could move very, very slowly in time or very, very fast. And we could also move through space at any speed or any rate that we like. So, to be more specific when it comes to the type of examples that we're considering within the code, let's consider the case in where we're firing every 3000 milliseconds and that we're moving forward every time 5 units. So if you think about a spectrum of motion and also of time, we would have the following. 3000 milliseconds elapse, we move by 5. Once again, the next time those 3000 seconds elapse, we fire and we fire and we move and we move and we move. And so you can see there where we can go from position 0 all the way to 25, and we're also making those time jumps along the way. Now, to ground some of those concepts, let's go ahead and do the following act of learning. In this case, you're going to have a time, a position, a velocity, and the velocity here maps to how fast you're moving forward. So at what rate are you accelerating or moving forward in physical space? And as you see there before you, you have my function, which is increasing your position based on the velocity, and then it's writing that position to the console. And then you have your set interval that is going to be calling my function over and over again. So let's go ahead and move to our console. I'm going to go ahead and reload the page. And as you can see there, the counter from the previous example continues to run. But once I do that, it's going to stop because I have cleared the memory by reloading the page. So let's go ahead and write that code. I'm going to start off by creating a time variable, and this variable is going to be 3000 milliseconds. That's going to be the speed at which we're going to be calling this function. The position that we're going to start off is at 0. And then I'm going to set a velocity. This is the rate at which we will move forward of 5. So a fairly small velocity. And when you want to see very smooth movements, you can go with a very small velocity. If you want to see big jumps, you would increase that velocity. Now I'm going to define my function. I'm going to call it here my function, just as before. Then going to write the function body. And the first thing that we're going to write, the first instruction is going to be the position. And that position is going to increase by the velocity on each function call. And then I'm going to write that to the console. So console.log. And then within it, I am going to write the position to the console. So I'm going to add to that position. I'm going to close my line there, and then I will write my interval. So set interval. I will give it my function name, which is my function. And then I will write the time at which this function needs to fire at. And so you can see there all of the parameters and all the variables that we have. We have time at 3000 milliseconds. We start off at position 0. Our velocity is that of 5. And so every time that function is called, we move forward when it comes to our position. So we're doing very much what we did in the slides of hopping every 3000 milliseconds, and we're moving forward in time, in this case, at the velocity of 5. So I'm going to go ahead and enter that command or those instructions, and you can see there that we start off at position 5, then we've moved to 10, we move on to 15, and we move forward in that manner. So if we go back to our slides, This is precisely what we had visually. Now we're executing it when it comes to code. So once again, I want you to consider about what is taking place, how rich this environment could be, what you could use it for. How do you think about the physical world, and is position here something that is relevant when you come to modeling systems? And how could you use this in your own context? Next, we're going to apply some of these concepts to the shapes that we define within the browser coordinate system. And to remind you what those are, remember that left is the horizontal axis, top is the vertical axis, and z-index would be z. Now, what you're looking at here is the definition of a page that brings together two concepts. The declarative programming we did initially, you can see there the div that has all of its attributes from z-index all the way to the color of the background. But note that we're adding one attribute, and that is ID equal ball. And we will use that once we are within this script to be able to get a handle on that div and to be able to move it based on what we want. So if we move to the bottom part of that code, you will see there that we are defining a velocity, a position, just like we've done. And then we're also getting a handle on that ball. So we use document get element by ID. We give it the ID, which is ball. And from there on, we have a handle on that ball. We also see there that we have the position, which will increase by the velocity. And then we set the property of the ball, as you can see there, to be left. So we do ball.style.left. And then we make it equal to position plus px. And the reason we use px for pixels is because that is what is required, as you can see here in the top declarative part, when you set your left pixel position. So in this case here on top, you have 0 px, and down here we have whatever it evaluates to, and we will add that px to make sure that we are setting the right values for the left left coordinate, which in this case is the horizontal axis. So let's go ahead and load that onto the editor. In this case, we're no longer going to be working on the console, and we have given you some starter code, so you don't have to retype all of this here. And so I'm going to go ahead and move to the class materials and download that zip next. So I'm going to move back to the browser, and as you can see here, we still have our execution running. But then I'm going to go ahead and navigate to dreamgrounded.io/workshop. And you can see here that the link for Wednesday has a zip file called simulation. I'm going to download that to my desktop. I'm going to save link as, and I'm going to save it, as I mentioned, to the desktop. I'm then going to unzip that folder, and I'll show you the contents in a moment. And you can see here that there are a couple of files that we will be using. We have MoveBall and MoveBall bonus. And so I'm going to load first MoveBall onto the editor. And so I'm going to go ahead and move to Visual Studio Code in this case, which is the editor I'm using. And as you can see here, you see the same code that we had in the page on the slides. And then you have a section there that says your code. Now in this part, I wanted to type this in just so you saw it come together. We're going to set the position, and the position is going to be based on the position that you currently have plus the velocity. Remember, this is the rate at which you're moving forward, your position. And then we're going to set the style. And as you can see there, we get the autocomplete, meaning that this editor recognizes that that is part of the browser. And so this is a horizontal axis position. And it's simply going to be position plus, we're going to add to it the symbol for pixels, which is px. And the first time this runs, we should be at position 5, so we will barely move. We're starting off at the origin. Note that we are at position left 0 pixels and top 0 pixels. So I'm going to go ahead and actually let me go ahead and start at 0, 0 here. So no movement on the velocity, and so we should simply be at the origin. And so I'm then going to load up the move ball file. You can see here I'm dragging and dropping onto the page, and you can see there that we have at the origin the green circle. I'm going to go ahead and go back to my code, and I'm going to go ahead here and move forward. I'm going to make my velocity much faster than I normally should if I want to see some smooth movement. But in this case, I simply want to make the point that we're moving. You can see there, if I go back and I move once again, you can see that I'm moving again, and I'm increasing by 100 every time. And so I'm showing you the way this potentially, if you were using a timer, would increase. So this is an example of doing it by hand. And the reason I want you to do this first is to make sure you're comfortable with the different pieces of the computation. You have this first part, which is the declarative part, lines 1 through 9. Remember, we're defining here the ID of ball. Then we have a script block that defines a couple of variables. It then gets a handle on that shape, and then we can manipulate it. We're setting a position rate of increase here. We're adding the velocity to it, and then we're simply setting the position on the horizontal axis, as you can see. So now it is your turn. Try it. Make sure you can do it. And I've just given you the demo. And so it is your turn. Go ahead and download that zip file. Play with the positions. Make sure you can do what I have done, and prove to yourself that you understand both the coordinate system and how you're setting those positions along the horizontal axis. I'm now going to move back to the browser, and I will drag the solution onto the page. And as you can see there, the ball is moving across the screen on its own, and it will continue to do so until it goes off the page. I should also note that I am moving at a specific velocity, and I could make it go much, much faster. Let me try to demonstrate that now. I've just changed my parameters, and now I'm going to reload the page. And as you can see there, in case you didn't see it, I'm going to go ahead and reload it again. It flies by. So once you get it working, this is the next thing that you'd want to do. Play with the rate of speed with which your ball will move. I just showed you a demonstration of what it would look like if you get everything working. Next, I'm going to show you the next set of functionality that we want to add to this moving ball simulation. The next thing that we want to do is we want to do edge detection. If you notice, the ball will continue to move off the page. And what we want to do is we want to set a certain limit. We want to detect the edge of a certain set of dimensions that up to you set within the page. And when you get to that edge, what you want to do is you want to reverse direction. So you will move to the right until you hit that edge. Then you will reverse direction, go to the left until you hit the other edge. You will reverse direction and go again. And so I believe the next page shows a demo of this. This is a concept of what you will do. You're moving forward until you hit the edge, and then you will return. You will reverse your direction. So let me show you what that looks like. So I've written a solution for edge detection, and I'm going to drag and drop that file. I've set the velocity to be pretty fast, so we should see that ball moving pretty fast from edge to edge. And yes, you can see there how it goes back and forth, back and forth, back and forth. So now it is your time to write the solution. This is one of those that once you get it, it's pretty simple, but it is not at all obvious what to do. So think about it hard, talk with your classmates. If you get stuck, raise your hands if you would like some hints. Once you master the horizontal axis, the x-axis, next you can try to do 2 dimensions. In other words, in this case, you have to keep track of 4 conditions that you must reverse velocity for. You have your horizontal axis, you have your vertical axis, and in each place you will need to place a limit. Now we've given you a starter code that was within the file that you downloaded. Not the file, but within the zip folder that you downloaded. And you can see there that the first part looks the same. However, when it comes to the script, you now have velocity x, you have velocity y, as well as position x and position y. So in the horizontal case, you have a much more simplified environment. You only have to keep track of 1 dimension. In this case, now you have 2D. So I'm going to show you next a demo of what it should behave like if you get it to work. And so I'm going to go ahead and drag that now. And this should also move pretty fast. And yes, you can see there that it is bouncing both on the horizontal limits of the space that I have defined and also on the vertical limits as well. And so you can see there that we have a pretty smooth simulation of a bouncing ball. Now, once you start down the road of additional considerations when it comes to this simulation, there's really a lot that you can do. Ultimately, you would end up with a physics simulator, but still at a pretty simple level, here are some of the things that you could do. You could change your speed every single time it touches an edge. You could change a color. You could change directions. You could change sizes. You could have multiple of them bouncing around at the same time. And so there's a lot that you could explore here. So I'm going to go ahead and show you here some possibilities of what you could do. In this first example, we have a change in color, as you can see there, once it hits an edge. On the next one, we have something similar, but we're changing the size. So you can see there. The next one is a change in speed. You can see that it moves in one speed in one direction and a different one on the other. Here is a lot of different balls moving at the same time at different velocities, as you can see there. You can even take this and move it in the X and Y direction. Another thing that you could do is you could do edge detection with some of the other balls that are moving, meaning when you come into contact with one of those, you could add audio. There's so much that you can do. And the point here is not to try to replicate everything that I have shown you, but to move through these concepts, make sure you understand them because they are illustrative of many of the things that you'd like to do in computation. And in a beginning level, when it comes to simulation, this can be a tool that you can use to understand a lot of what you might want to try to do. And at the very least, it's a way to explore many of the concepts that we have shared with you in this workshop. So with that, go ahead and enjoy and try to push as far as you can on some of these notions. So with that, I wish you happy coding and goodbye.